Now we're going to work on problems 6 through 10 of the MCA practice tests. Feel free to take notes again as we go through it. Question number 6. How can the following compound statement be combined into a statement using absolute value? This is going through and testing some algebra and seeing what happens when you do absolute value. Let's go through. This one's kind of a guess and check, but I'm going to go right to question C, because question C, I'm noticing I can get, from question C, I can get a 5. I look at these 3 and a 2, and I can get a 5. I can also take a 3 and a 2, and somehow I can work with a 1. So I just thought, well, same thing with this one. You can get 3 and the 2. But I think what I'll do is I'll work with the first one, letter C, just to see how that works. And we'll go from there to figure it out. When you deal with absolute value, what happens is you rewrite the equation, x minus 2 less than 3, exactly as you would see it. Notice it's the exact same thing. Then what happens is you do the same thing, write it again, but this time x minus 2, change the symbol, so switch to greater than, and switch the symbol on the number that's equal to. So in other words, I need to flip this, and I need to flip this to a negative instead of a positive. At that point, you solve both equations and see what happens. I'm going to add 2. So in this case, x is less than 5. And then I'm going to add 2 here as well. And in that case, I get x is greater than negative 1. Then I go back up and look. What are they looking for? Something x less than 5 and x greater than negative 1. I've accomplished both of those with this problem. Therefore, this is my best answer, C. Again, to rewrite it, you write it exactly the way you see it, and then you switch the symbol and switch it from a negative to a positive or vice versa. Then solve both equations and get your final answer. That's question number 6. Let's look at the question number 7. Tickets for a concert cost $15 each, plus $1.50 each for handling charges. The shipping fee for an order of any number of tickets is $4. Which equation could be used to determine the cost C of any number of tickets? So I kind of go back and think, all right, well, $15 for each ticket that I buy. So I got to remember that. $15 for each ticket, so times ticket, plus $1.50, so I took care of this part. Plus there's a $1.50 charge for each ticket for the handling charges. So not only is it $15 just for the ticket itself, but they're going to charge me $1.50 for each ticket that I'm purchasing, so that they can, it's called the shipping and handling. The handling charges is what they use to pay somebody to organize the tickets and put it in an envelope and mail it to you. But alongside that, there's a shipping fee for an order of any number of tickets is $4 or $4. In other words, no matter how many tickets I order, it's just going to cost me $4 if I order 1 ticket, or if I order 50 tickets. It's still going to cost me $4 to get it out the door and get shipped to my house. So this is going to be plus 4, but it's not times tickets, because the tickets don't matter at that point. It doesn't matter how many I get, it's still going to be a $4 charge. Okay, I think I've broken it down. Now I look and I can say that this is going to be equal to my cost for my full equation. And at that point I say, is there any terms I can combine? Let's find like terms. And I see right here, I've got like terms. 15 plus 1.5 gives me 16.5 t's, plus the 4 gives me my cost, or my total cost for the ticket. Go back, let's see which one matches up, and there it is. My answer would be B in that case. All right, let's move on to question number 8. Yea wrote the equation P equals 0.25n minus 0.05n plus 1 to represent the school store's weekly profit P from sales of n pencils. Which equation is equivalent to Yea's equation? In other words, they've done some distribution and figured out I can combine some like terms to go from this answer, from this full thing, to something shorter, which is one of these answers. Well, let's go ahead and figure out how this is going to work. P is equal to 0.25n minus, I like to say there's a 1 here, even though we don't write it, so we can see what needs to be distributed. 0.05n plus 1. Let's go ahead and distribute this net minus, or the minus 1 in this case, to everything inside the parentheses. So 0.25n minus 0.05n, because minus 1 times 0.05 is a negative 0.05, plus, and then you've got minus 1, again, times the plus 1, which is a minus 1. And that, of course, is equal to p. That won't change. All right, I've done my distribution. Can I combine any like terms? And again, I see I've got 2 here I can combine. 0.25n minus 0.05n. It's like 25 cents minus 5 cents leaves me with 20 cents, or 0.20n. And then this plus a minus 1 can also be written as just minus 1. That's equal to p. So I can rewrite that if I need to, 0.2n minus 1. These two are the same thing. Just depends on how you see it. And let's go up and see if any of these match with our correct answers. And for our answer, I see that we are matching up with A. So A is going to be our best answer right off the bat. It matches up, 0.2n minus 1. Again, this is algebra. You're working on your distribution, and combining like terms is what they're testing in question number 8. Let's look at question number 9. Question number 9 is a little bit more in depth. And what they're doing is they're looking to see, can you fill in the equation, even though it might look ugly, and then see what happens from there. In an electric circuit, the power dissipated in a load can be modeled by the equation P equals IV minus I squared R. The following chart tells what each variable in the equation represents. In a certain circuit, the voltage supplied is 100 volts, and the resistance of the rest of the circuit is 25 ohms. Which of the following currents can be present if the load is expected to use 75 watts of power? And then they go through and say P is equal to the power used in load watts, V is your voltage, R is your resistance, I is your current in the circuit in amperes. All right, when you get a problem like this, the best thing to do is go back and reread it. Read it through once, go, what are they looking for? Go, huh? You see the equation. Some people panic in the equation. They've given us some information. Let's see if we can fill in where that information is. First number I see, the voltage supplied is 100 volts. Volts is V. So I'm going to say, all right, well then this 100 must go in for V. Then I read on, the resistance of the rest of the circuit is 25 ohms. All right, well, ohms is going to be R, resistance of the circuit external to the load in ohms. So this 25 is going to go in for wherever we see R. Which of the following currents is present if the load is expected to use 75 watts of power? 75 watts, again, we're going back, that is our power. So 75 has to go in for the P. So far, all I've done is fill in the information they've given me. Let's rewrite it so we can see it. 75 is equal to I times 100 minus I squared times 25. Now, you can go through and try and factor this, but a lot of people in this case would go, I'm not exactly sure how to factor it. So remember, the answer is there in front of you. And when you ever take a multiple choice test, that's the best scenario because the answer is there in front of you. So in terms of having to guess and check, take the answers and start plugging them in and see what works. So what I'm going to do is I'm going to work with this 3 first because it's the first one. It's letter A. I'm just going to plug that in for I. So I'm going to put, does 75 equal, question mark, because I don't know, 3 times 100 minus 3 squared times 25. And let's see how this works. 3 times 100 is 300 minus 3 squared, which is 9, times 25. The 75 on the left-hand side, I'm not sure. That's what I'm wondering. Are they equal? 300 minus, let's finish this, 300 minus 9 times 25, which is going to give you your 225. which is 75. Does that equal 75? Wow, nice. Right off the bat, we have found that 75 equals 75. In other words, the number that we have plugged in for I, this number that we plugged in right here and right here, actually came out to be true. So this is, in fact, what we call true. So my best answer is, in fact, going to be A, because the equation holds true for that number. Let's say you get a problem like this and you have to type it into your calculator. So here's our calculator, and I want to go through and type this in. I'm going to hit clear, get out of this, and let's type it in. Okay, so the first number is 3 times 100 minus, and then I'm going to put in parentheses just to be sure, 3 squared times 25. Close my parentheses, see what it gives me. My answer is 75. That's what I was looking for. Let's say my answer wasn't true and you have to try the next number. Let's try the next number, which was, let's see what it was. The next number was 5. So I'm going to try 5. Let's just say it didn't work. I just want to show you a trick. I can just do second enter, and what I typed in last comes back up. So I don't have to retype this whole equation. I don't have to retype that whole thing. I can just go back and change these numbers to a 5. Let's go here. That 3, I want it to be 5 instead of a 3. And then the 100 times 3, I'm going to change that 3 to also be 5. I hit enter, negative 125. Well, the 75 does not equal negative 125, so I know the 5 doesn't work. My point with this was to show you that sometimes it's nice if you have a long equation, you type it in. If you hit second enter, what you typed in last comes back up with a cursor. So now you can move that and you go, all right, well, what if I wanted to try 8? Plug 8 in here, and then I can go to the left some more and try 8 in that spot. Then you just hit enter, and you don't have to keep typing it in. You can just keep trying those numbers. Just wanted to show you that as a nice trick for the TI graphing calculator. All right, let's look at question number 10. Use the diagram below to answer the question. This is a combination between a little bit of geometry and a little bit of algebra. It says the yearly growth of a tree is modeled by concentric circles in a cross-sectional cut through the tree trunk as shown. The 1-year-old tree has a diameter of 2.5 centimeters. Which equation models the diameter of the tree, D, in terms of the age of the tree in years? First thing you want to do is go back, reread the equation, or the problem, and then look at the picture and say, what do we know? And really break down this. In this case, in this information, this is important. The diameter of a 1-year-old tree is 2.5 centimeters. So right off the bat, we know our tree is 2.5 centimeters. It says, what equation models the diameter of the tree, D, models the diameter of the tree, now give me an equation, D, in terms of the age of the tree in years. Well, the diameter is equal to, right off the bat, I know it starts at 2.5 at the first year. So we're going to say 2.5 because that's where we're starting. And it's not growing. Now let's go back and look at this. After 1 year, I'll use a blue pen here. After 1 year, it's gone from here to here. It's grown this much. And they're telling us that distance is 1 centimeter. So after 1 year, after another year, it's already 1 year old, and after 1 year it was 2.5 centimeters. After 2 years, it was 4.5 centimeters. So it went from 2.5 in the first year to 4.5 in the second year. In other words, it increased 2 centimeters. So right off the bat, I know it's got to stay 2.5. So that takes out A and B as a possibility. That leaves me with two answers, either C or D, and I have to figure this out. A lot of people would go, well, it's just 2 times the number of years. Not exactly, because what happens is if you look at this, it has grown in 1 year only 2 centimeters. But this was the second year. So how do we go from 2.5 to 4.5? We increased 2. So let's go ahead and try and figure this out. So let's go, all right, plug in some numbers. 2.5 plus 2n. Let's see if that works. So after 1 year, it's 4.5. Except that after 1 year, it was only 2.5 centimeters. So this, I'm not sure that's going to work. Because again, after 1 year, it should be 2.5, and it's only, in the equation, sorry, gives us 4.5. Let's try the next equation. Let's try this one, the part D. 2.5 plus 2 times the number of years minus 1. Well, if I try the first year, we get 2.5 plus 2 times the first year minus 1, which is 0. And 2.5 plus 2 times 0 is just 2.5. That actually holds true. After 1 year, it's 2.5 centimeters because that's what they told us right here. Let's just, for the sake of it, try another one. Let's try 2.5 plus 2 times the second year, which is 2 minus 1. 2.5 plus 2 times 1 is equal to 4.5. That makes sense. If you go back up here, remember, after 2 years, it was 4.5 centimeters. The 2.5, which it was originally, plus it grew an inch on either side of that, in other words, another inch. So it became 4.5, and that's what this equation gives us. 2.5 plus 2 times the number of years, which was the second year, minus 1, the first year where it was just 2.5, which gives us 2. 2 times 1. Add that to the 2.5, gives you your 4.5. So again, that works. You're always welcome to try another one if you want to. Here's your third year, and after your third year, it's 6.5. So let's try that one more time. 2.5 plus 2 times the third year minus 1, which makes it 2.5 plus 2 times 2. This gives us 4 plus the 2.5 gives us a total of 6.5, which matches what we said it should be. So my answers end up going to be D. So process of elimination, I knew it had to be 2.5 to begin with, so right off the bat it took off there because it's not growing 2.5 each year. It left me with C or D, so plug in a number, kind of see what happens. After 2 years, it was 4.5 centimeters. That matches up with this. That's what this equation was, right down here. And you can kind of see your work from there. So again, in this case, sometimes it helps to do a little plug and chug. Try and eliminate, remember the answer again in front of you, try and eliminate a couple of the answers if you can. Once you've eliminated, you've got 2 problems, then just plug in some numbers, but the key here is to break down this picture so you see what it looked like, what happens each year. That gets us through questions 6 through 10. Hope it helps.